Now, it's kind of interesting to note that it was Newton also who proved that the distance to the center of the Earth is where you should measure when you're trying to figure out the force of gravity. Think about it. If you were standing at X, and let's say the yellow circle was the surface of the sun or the Earth, let's say the sun, how strong is the pull of gravity? You notice that some of the sun is close to you, some of the sun is further away, and Newton was able to prove mathematically that the sun pulls on external objects as if all the mass were concentrated at the center. If you happen to have taken a calculus class, it might be fun to realize that Newton invented calculus to solve problems like this. So you can show in calculus, and it's kind of fun to do, that if you add up all the poles of all the places inside the sun, they add up as if all the mass was at the center. So it makes it easy to measure. But how about inside the sun? If we're going to understand the overall structure of the sun, we have to understand not only the surface, but all the way down to the core. So how about if you're at position X inside the sun? Well, Newton solved that problem too, and he figured out that the exterior shell, the yellow or the orange, cancels out. Some of it is pulling you outwards. Some of this shell over here is pulling you inwards. And the combination of all the orange in this picture just cancels out. Whereas the white, which is interior to you, acts as if it's concentrated at the center. So you can figure out the pull of gravity not only at the surface of the sun, but all the way down to the core. Knowing how gravity works, we can calculate the pressure that it exerts throughout the sun. And then we need to know, how does pressure affect gas? Well, fortunately, there's an app for that. Of course, it's a PhET app. Let's use the PhET applet to figure out what determines the pressure of a gas. If we start to add more atoms or molecules, the pressure, the force that's felt on the side of this container, or the force that's felt by the pressure gauge, goes up. And so as we add more, we get more pressure. But that's not the only thing that affects the pressure of a gas. Suppose we heat the gas, make a little fire here, and you can quickly see that the atoms or molecules are moving faster. And the faster they move, the higher the pressure. So temperature also affects the pressure of a gas. And in fact, those are the only two variables that determine the gas pressure. Pressure is proportional to temperature, and it's proportional to how many molecules or atoms there are. To be a little more precise about that, it's proportional to the density. So if I was to, rather than adding more atoms or molecules, just reduce the size of the container, that would also increase the density and increase the pressure until we blow our top.